If you've worked in the mechanical trades for any length of time, chances are you've seen a pressure test fail. Pressure testing is a common procedure in our industry. Any system installed sees a pressure test anywhere from 10 pounds to thousands of pounds per square inch. When a pressure test fails, there's a sudden release of stored energy, and it's sudden, violent, and can cause a lot of damage.
Possible hazards can include flying objects like valves, flanges, gauges, fittings, and shattered piping system pieces. Respiratory hazards such as oxygen displacement from inert gases, and electrical hazards from flooding in areas where there's energized electrical equipment. Injuries can also be serious. Puncture wounds, broken bones, lacerations, asphyxiation, electrocution, and many others.
A few years ago, we had an apprentice that was working near a 6-inch galvanized domestic water line. He noticed that one of the clamps was leaking. Because the pressure was in the pipe, the worst thing you could do is actually try to press those gaskets together because it's not going to repair the situation. He decided to take an impact wrench and tighten that clamp down while the pressure test was still going on. That was the wrong move to make. When he actually tightened that clamp down, that internal pressure and him putting that external pressure on it caused the clamp to explode, striking him in the hard hat. It was the hard hat that saved his life that day. This is the hard hat that our apprentice was wearing during the incident, and you can see the result of what the clamp did to the hard hat. I mean, it's just absolutely destroyed.
To help you prevent these consequences, we're going to cover the basics of hydrostatic pressure testing, pneumatic pressure testing, common causes of pressure testing failures and protective measures to prevent common failures, walkdowns, and other general safe work practices.
Keep in mind that we're only talking about steel and copper piping systems, not cast iron, plastic, or fiberglass systems. Let's start with the basics of hydrostatic testing on steel and copper piping systems.
Hydrostatic testing is always a better option than pneumatic testing because there's considerably less stored energy. In hydrostatic tests, water or some other liquid is pumped into the piping system before it's pressurized. Since liquids can't be compressed like gases that are used by themselves in pneumatic tests, hydrostatic testing is a much safer process. You won't always be able to perform hydrostatic testing, but whenever you can, it's the safest way to go. Pneumatic testing is much more hazardous because compressed gases store energy at test pressure levels. Consider this. If you've got 500 feet of 6-inch pipe bearing 150 pounds per square inch of pressure, that's the energy equivalent of roughly 5 pounds of TNT. That's why you don't want to perform pneumatic testing unless it's absolutely necessary.
But if you understand why most failures occur, you'll be able to perform pressure testing operations much more safely. Let's look at some common pressure testing failures and what you can do to prevent them.
One of the most common failures is overpressurizing a piping system. To avoid this, determine the safe test pressure and the length of the test performance. A lot of information goes into that calculation, so before you start a test, make sure you check with your supervisor to determine the correct test pressure and minimum test performance time.
It's also a good idea to have some basic knowledge about the materials you're working with, so you can raise the red flag if you somehow get incorrect test pressure information.
When you start the test, increase the pressure gradually and use the established hold points consistently. Common hold points for hydrostatic tests are at the initial filling of the system, at 50% pressure, and at final pressure. The same hold points are also commonly used for pneumatic tests, but it's a good idea to add an additional hold at 75% pressure.
Be sure to learn and follow your company's standardized operating procedures for each specific test application, and never, ever exceed the established test pressure.
Using inadequate or improper pressure testing equipment also leads to failures. Inadequate equipment includes poor quality or damaged gauges, pumps, hoses, connectors, or other system components, equipment that isn't designed for the maximum test pressure that it will need to handle, and equipment that's not properly calibrated or just not functional. And when you're working in the winter, be sure to consider the temperature. Sometimes the gauge inlets freeze, which can cause excessive pressure in the system. Check that the equipment you use is made only by reputable manufacturers. And inspect it before you use it. If you detect any excessive wear or damage, follow your company's procedures for taking defective equipment out of service and replace it immediately. Before the installation, make sure that all test gauges register 0. If they don't, take them out of service immediately and replace them. If you're not using a brand new, properly calibrated gauge, check the calibration stickers on each gauge to ensure that they've been professionally calibrated within the past 12 months. Improper system design is another common failure.
If a fitting, valve, flange, or any single component won't stand up to the pressure, the system will fail. For instance, some system valves may be inadequate for pressure testing.
An example would be a butterfly valve that doesn't seal properly. When that occurs, you'll need to use a blind or another positive isolation mechanism to perform the test. Verify ahead of time that the system is designed properly. If you determine that a system component might not handle the test pressure, or if you're just not sure, check with your supervisor before you start. Operator error is another common pressure testing failure.
Errors usually happen when workers get distracted or feel rushed. No matter what's happening around you, always carefully follow your company's standard operating procedures and safe work practices for pressure testing, and always follow the equipment and material manufacturer's recommendations.
And never participate in a pressure testing operation until you've gone through proper training. When repairs or modifications to a piping system aren't done right, failure is inevitable. So, before you start the test, inspect the entire piping system for misalignments, improper fittings, rolled or cut gaskets, and anything else that could cause a failure. Make any necessary corrections before pressurizing the system. Another major cause of failures is forgetting to isolate the parts of the system that won't be tested. Be sure to review the piping system drawings or models and any pre-test safety planning procedures before you pressurize the system. Create a pre-test checklist that includes the specific parts that must be isolated or blocked, and follow it carefully so you don't inadvertently forget any of them. Equipment that's not properly isolated from the pressure test can also cause massive failures. Most equipment that arrives for installation has already been tested, but because the safe test pressure for equipment is typically lower than for the piping system, it needs to be properly isolated to protect workers and prevent damage. So make sure you include equipment isolation on your pre-test checklist. Before pressurizing any piping system, you need to perform a walk-down to make sure that everything's in order.
A walk-down is nothing more than a detailed inspection of the piping system performed immediately before the test.
You're looking for several very specific things, but for the most part, they're the same for both hydrostatic and pneumatic testing. First, identify any equipment in the test area that could be affected by a failed test and do whatever's necessary to protect it. This includes owner's property that could be damaged. These areas should be checked routinely throughout the testing. Look to see that the piping system matches the 3D models or drawings and that no parts of the system have been left open. Make sure that all joints and connections are exposed and easily visible during the test. Look for damaged components, misaligned segments, and anything else that seems out of place. Carefully inspect each part of the system that won't be tested to make sure it's properly isolated from the parts of the system that will be tested. Verify that all necessary lockout and tagout procedures have been completed properly.
There are 3 additional walk-down items that apply only to hydrostatic testing.
Make sure the system is properly vented at all its high points. That allows the air to bleed out when the liquid test medium is added to the system. Make sure that proper water drainage and collection points have been established where needed throughout the system.
And don't forget that if it's cold enough, residual water in existing systems can freeze, which could break one or more system components.
Now let's look at some of the other general safe work practices. No matter what type of pressure test you perform, the personal protective equipment is pretty much the same. You'll always need a hard hat, safety glasses and gloves, and if standard operating procedures call for it, a face shield and hearing protection.
However, there are a couple of key differences in safe work practices for hydrostatic and pneumatic tests.
For hydrostatic tests, you'll have to close off and seal the vents once the air pockets are bled out of the system. For pneumatic tests, you'll need to verify that the test medium is neither flammable nor toxic. Be sure to confirm with your supervisor what test medium is preferred for each application.
The rest of the general safe work practices apply to both hydrostatic and pneumatic testing.
Be sure to install a pressure relief valve. By installing the valve, you'll substantially reduce the risk of overpressurizing the system. Make all the necessary system component replacements and repairs you identified during the walkdown. In the rare case you're working in extreme cold, verify that the metal's temperature at the time of the test is satisfactory, since extremely cold materials can be brittle, which makes them much more likely to fail. Use 2 pressure test gauges, one at the pressure source and the other at the highest or furthest point from the pressure source. Choose gauges that place the test pressure as close as possible to the 12 o'clock position. For example, if the test pressure is 150 psi, use a 300 psi gauge, which will put test pressure at the top of the gauge. Barricade the test area with red danger tape to keep non-essential people out of the area. Before you start to pressurize the system, confirm that there are no non-essential people inside the pressure testing work area and inform everyone in the surrounding area that the test is about to start. Even after the initial test is over, you're not quite done. Carefully and gradually bleed the pressure from the system according to the established standard operating procedures. Then make any necessary repairs and retest the system.
Because our tradesmen are constantly doing pressure testing, sometimes they forget the hazards associated with it. The 2 most important things to consider when doing pressure testing are communicating the test to coworkers and other trades in the area, and also for coworkers to understand that no system should ever be worked on while under a pressure test. This hard hat stays near my desk as a constant reminder of the dangers of pressure testing.
Whether you're performing a hydrostatic or pneumatic pressure test, you can prevent injuries by remembering to do the following.
Respect the pressure. For pneumatic tests, even 15 to 20 psi is intense pressure. Never remove a system component under pressure. For hydrostatic testing, be sure to consider elevation. Every couple feet of rise increases the pressure, so pumping the high point may overpressurize the bottom of the system. And always, always control the release of energy through a valve. Be aware of what causes pressure testing failures. Implement the appropriate protective measures to eliminate those failures. Just before the test, perform a thorough walkdown to make sure the system is safe and properly prepared for the test. Carefully follow your company's standard operating procedures for each specific pressure testing application and comply with all the appropriate general safe work practices.
Performing any kind of pressure test incorrectly can do a lot of damage to workers and to equipment. The best way to protect yourself and others is to consistently follow the safe testing practices you learned today.